Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. Today's session will discuss about the problems on autocorrelation function. Okay, first we'll go for problems on different types of problems on sinusoidal process, problems on autocorrelation of exponential decaying process. First we'll go for quick overview of the autocorrelation properties. Rxx of tau must be less than or equal to Rxx of 0. Means autocorrelation is maximum at the origin. Next, second property tells that autocorrelation is even symmetry. Rxx of minus tau equal to Rxx of tau. Next, third property tells that autocorrelation function is equal to average random process. Average power of the process. Next, fourth one tells that if x of t is stationary and ergodic with no periodic components, then limit tau tends to infinity Rxx of tau equal to mean of square. Next, if x of t is stationary and has periodic component, then autocorrelation function has a periodic component with same period. Autocorrelation function is also periodic component with same period. Next, autocorrelation function of a random process cannot have any arbitrary shape. Okay, just a quick revision before going to discuss the problems. Now we will discuss the problems based on autocorrelation function of a sinusoidal process. Means any sine or cos function. Here I consider let x of t. X of t is a random process. A is the amplitude. Cos is the function. Omega naught is the angular frequency. Okay. Here we are taking with respect to time, and theta is a random variable. Okay. And omega naught is a constant. Okay. And A is also constant. Okay. Now here theta is the random variable uniformly distributed over the interval 0, 2 pi. Determine the autocorrelation function. Now we know the definition of autocorrelation function. Okay. If we are considering here as a process is a wide sense stationary, then the definition is Rxx of tau is equal to expectation of x of t into x of t plus tau. Now before solving this, first you have to know what are the variables here having. Okay, here we consider that A and omega naught are constants. Next, theta is uniform random variable defined over the interval 0, 2 pi. Okay. Now next, how to calculate this? Okay, when theta is a uniform random variable, we know the definition of density function f of theta is equal to, okay, here it is defined over the interval 0, 2 pi. Okay, this is some, okay, whatever the things theta, f of theta, then what you are having, it is defined over the interval 0, 2 pi, then the difference 2 pi minus 0, that is 1 by 2 pi, defined over the interval 0 less than or equal to theta less than 2 pi and 0 otherwise. So this is the density function definition of this problem. Now next we will discuss about how to solve this one. We have to apply the expectation of x of t. You know that expectation of x of t is a cos omega naught t plus theta into a cos of omega naught in place of t plus tau plus theta. Now multiply here, then you get a square cos omega naught theta plus theta cos omega naught t omega naught tau plus theta. Okay, now what you are having, this is to solve this one, you have to further simplify it. Okay, expectation of a square is constant. Just multiply and divide. A square you can take outside. Expectation of constant is constant itself. A square, multiply and divide by 2. Then expectation of 2 cos A cos B. Okay, this one you can consider as A, this one you can consider as B. Then you know the formula 2 cos A cos B. 2 cos A cos B equal to cos of A minus B plus cos of A plus B. Okay, this is a formula. Then what you are going to get? A square by 2. Then what you are going to get here? Cos of A minus B. Cos of A minus B, if you subtract this, then you will get omega naught tau plus cos of A plus B. Then what you are going to get? 2 omega naught t plus omega naught tau plus 2 theta. Now it is easy for the simplification. You take this one. Okay, now this part is important. Now we have to simplify it further. Okay, this one we have to simplify it further. Apply the expectation for this. Okay, we have to apply the expectation for individual terms. Okay, then what you are going to get? A square. Okay, now A square by, okay, now I will write here what you are going to get. A square by 2, first term, A square by 2, expectation of cos omega naught tau. This is the first term. Then what you are going to get? A square by 2, here integral. Okay, cos expectation of x is integral minus infinity to infinity x into fx of x dx. Here the x value this is. But here we required what? Expectation of cos omega tau. Okay, cos omega naught tau into f of theta d theta. Here theta lies between 0 to 2. Then what you are going to get? Okay, you take this constant outside. A square. Okay, A square by 2 cos omega naught tau. Here this is 1 by 2 pi. 1 by 2 pi. Here what you are having? 2 pi minus 0. Okay, this term also will get cancelled. You will get only A square by 2 cos omega naught tau. So this is the first term. Second term, we are having the second term also. Okay, first term you got the output, that is A square by 2 cos omega naught tau. Okay, first term, what is the first term you got? A square by 2 cos omega naught tau. Okay, now second term is also there, that is A square by 2. Okay, expectation of cos 2 omega naught t plus omega naught tau plus 2 theta. Now again this one also you have to keep the expectation. A square by 2, theta lies between 0 to 2 pi, cos 2 omega naught t omega naught tau plus 2 theta f of theta d theta. This one you know it already, this is 1 by 2 pi. Okay, you take outside that, then this one you apply it, then what you are going to get? A square by 4 pi. Here sin 2 omega naught t omega naught tau plus 2 theta by 2 0 to 2 pi. Okay, you simplify it further. Here when you simplify it, okay, here 4 pi you will get. Okay, it repeats every 2 pi cycle. Sin of 2 pi is 0, sin of pi is 0, sin 0 0. When you subtract it, you will get 0. Then the remaining term will be 0. And finally the answer for this, determine the autocorrelation function, you will get only the first term, that is A square by 2 cos omega naught tau. This is the solution. Okay, x of t equal to A cos naught omega naught t. X of t plus tau, just substitute in place of t plus tau. Then multiply the product, then you will get the resultant. Then apply the trigonometric property, you will get this resultant. Now next, you simplify it further, then this term will become, okay, cos of minus theta is cos theta itself, you get only this term, and this term will become 0. Okay. Now we will discuss the second concept, autocorrelation function of exponentially decaying process. Exponentially decaying process. Okay, consider a process x of t equal to a into exponential to the power of minus alpha into t, where t greater than or equal to 0, where a is a random variable, expectation of a square equal to sigma square, and alpha is greater than 0, find the autocorrelation function. Okay, here also same concept. Okay, just first identify what are the variables we are having and what are the constants we are having, then based on the definition apply it. Again, the same autocorrelation definition, you know that expectation of x of t into x of t plus tau. Here t is a variable. Okay, here expectation of a into e power minus alpha t plus a into e power minus alpha into t plus tau. Now a constant this is, we take outside a square expectation of e power minus alpha t e power minus alpha t minus alpha tau. Okay, you add this one, you simplify it further. Okay, simplified already, just to check it. Okay, expectation, this is the definition. Now you apply the calculate this one. This is constant. Expectation of constant is constant only. Expectation of a square into this term. Okay, expectation of a square is already discussed in the question. That is sigma square. Sigma square. You substitute that sigma square e power minus t. Okay, for tau greater than or equal to 0. Now next question. A stationary random process has autocorrelation function. Find mean, mean square and variance of the process. Okay, first to calculate the mean process. Okay, this one we had to calculate by using the properties. Okay, we discussed the properties in the beginning of the lecture. Okay, by using these properties we are going to calculate this problem. Now next, okay, here you can check it. Rxx of 0 is equal to expectation of x square of t. This is one property. Next, second one, limit tau tends to infinity, Rxx of tau is equal to x bar square. This is one of the property. Next, variance, you know the property of variance of x of t, which is equal to expectation of mean square value minus mean of mean square minus mean of square. This is a mean square value, this is mean of square. Based on these three formulas, we are going to simplify this problem. Now we have to simplify this problem. First, okay, for simplification, just first we go for r tau equal to 0. Okay, Rxx of 0, which is equal to 25 into 0 plus 36 by 6.25 into 0 plus 4, which is equal to what? Expectation of x square of t. Then what you are going to get? This part 0, 4 by 9 means expectation of x square of t is equal to 9. Expectation of x square of t equal to 9. Now we got mean square value. How to calculate the mean value? Okay, mean square value we got 9. Then okay, just write it one side. Expectation of x square of t equal to 9. Now next, mean value. We know the formula, limit tau tends to infinity, Rxx of tau equal to x bar square, mean of square. Okay, mean of square. Now you simplify it. Limit tau tends to infinity. Just you rearrange that. Take tau square common. 25 by tau square. Okay, you take 25 plus 36 by. You can keep like this. Okay, you can keep like this, or tau square you take common by tau square 6.25 plus 4 by tau square. Here tau square will get cancelled. Here limit tau tends to infinity. This part will become 0. This part will become 0. 6.25 means 25 by 6.25, which is equal to 4. x bar square is equal to 4, x bar equal to 2, means mean value equal to 2 and mean square value equal to 9. Okay, then what you are having? Variance. Variance is equal to what? Okay, this is 9 minus mean of square, means 2 square, that is 9 minus 4, that is variance. This is a variance of the random process. Okay, this is the way you have to solve. Okay, in this lecture we have discussed different types of problems related to the autocorrelation function. Thank you.